Hello everyone, welcome back. This is Chandan and you are watching the learning field. So as I have already shared with you that I will make the ordinary differential equations lecture series as I have already shared in one of my, I think one or two of my the recent lectures of any topics. So this is the lecture series for ordinary differential equation that is completely designed for CSIR NET exam, GATE exam, SET exam, and any other exams. Most commonly, if we will cover the syllabuses for CSIR NET exam and GATE exam, then any exams of higher maths that includes the ordinary differential equation in the syllabus will be covered. So now, as you already know that the syllabuses for the CSIR-UGC NET exam has changed and it will be applicable in very near future of the upcoming exams. So we will focus on the new syllabus of CSIR NET exam and also for the GATE exam. So first, I will share the syllabus. So this was the syllabus for the existing CSIR NET exam. So see the existence and uniqueness of the solutions. Actually, this starts from existence and uniqueness of solution. Then first order differential equation, the different types of solutions, system of first order, general theory, homogeneous. So the syllabus was very less that mentioned in this topic for the CSIR NET exam, and this is the syllabus for GATE exam. Actually, the syllabus for the GATE exam is a little bit heavier than that of the CSIR NET exam because in this in this syllabus, power series, Frobenius method, Legendre Bessel polynomial, orthogonal properties, all the things, planar autonomous system, Lyapunov function, linear stability, all the things of the differential equation already included. But the new syllabus for CSIR NET is this one. First order differential equations, existence and uniqueness of solutions, then the initial value problems in linear ordinary differential equations, and all the things. Okay. So I already make a video that what are the changes of CSIR NET exam. I will share the link in the description and also here in the item. You can check. Mostly the changes that occur in the ODE portion. Okay, mostly the changes ODE and PD portion that I have already shared. So in here now the power series Frobenius method, Sturm-Liouville oscillation problem, all the things now included, Lyapunov functions in two variables, all the things. That is now the CSIR NET syllabus and the GATE syllabus are mostly same syllabus and a little bit heavier for CSIR NET exam. Already, if you notice in some recent year questions, the trend of the questions was a little bit tough than the suppose 4 to 5 years before ago the questions level. So now we will focus uh, according to the new syllabus of CSIR NET and also for the GATE exam. See, the only difference is the what the Legendre and Bessel polynomial orthogonal properties. They just only a small portion. This is not include in the CSIR NET syllabus or one or two terms maybe. So we will cover the syllabus in such a way that all the things of CSIR NET and GATE exams will cover. So we'll start from a very basic and we will go up to a certain high level also. Right? So now I will share you some of the very good book for ordinary differential equation. See, most of you already read some books like MD Raisingania. See, in MD Raisingania is a good book for beginners. But nowadays, if you want to solve the questions papers of CSIR NET, only I think only MD Raisingania is not enough for ordinary differential equations as well as the partial differential equations. I will also try to make the lecture series for partial differential equations also. So if you are interested, then let me know in the comment section below. So I will share the books like first one is differential equation, differential equations by S.L. Ross. And this is a very good book for ordinary differential equation and starting. See, these books are written such a way that if you read the books very carefully, you will understand one by one topics. So I'll just share that for my interview of PhD, I have followed this book for ordinary differential equation. You can learn many things that you have. I can guarantee that you have not learned yet. Okay. Number two book is, the book name is differential equations with applications and historical notes. This book is written by George F. Simmons. So this is also a very good book for ordinary differential equation. Number three that we use for our lecture series is elementary differential equations equations and boundary value problem. By this book written by Boyce, the Prima and Mead. This is our third book that we will use, and the fourth book that we use is an introduction to differential equations. And their applications. Right? And their applications. This book written by Stanley A.J. Harlow. So these are the four books mainly that we will follow. And see, if you have any other books, then you can definitely follow. All the books are good for any perspective. Fine. So, and one more thing is that in some of the cases, I will use some another book that I will also mention in the lecture series, that is need that actually I use. Okay, I will refer all the things. So these are the main four books. Now, actually, if we see very basic things of differential equation, see today is the first lecture, and I will not going to very deep section, that I will just introduce the ordinary differential lecture series and just start some of the things. And one more thing is that I will try to make all the lectures from 15 to 20 minutes so that you can easily watch one by one lectures. Fine. Because I know that if the lectures is very big, then the focus is very less as the time increases for one by one lectures or time lecture series. Okay. So definition, it says that equation that involving the derivatives of independent variable with respect to the dependent variable and the variable itself is called a differential equation. See, we will not uh, go into actually ordinary differential equation or partial differential equation. We will just start through ordinary differential equation, and there are far better definition than this definition. This is just a very basic definition of differential equation. Now, the differential equation, if we see some higher things, that then the differential equation in some books, the differential equation is written as a function of x, y, y dash, y double dash, and so on is equal to 0. And also for if the partial differential equation, then z, z dash, and so on. So this is if the functions and their derivative includes in an equation, then we say that this is a differential equation. Now we all know that the differential equation is of two types mainly: ordinary differential equation and partial differential equation. Now the very basic definition of ordinary differential equation is the based on, actually they actually differ based on the number of independent variables, right? The number of independent variables. Now, what is the independent variable? So, if y equal to fx, we write, then there are two variables, x and y, we all know that. And this y variable depends on x, right? So, if we write simply y equal to 5x plus 6, see the value of y depends on x, but x is not depend on y in this case. That means in this case we say that this x is the independent variable. Now, in case of ordinary differential equation, the number of independent variable is 1, and for the partial differential equation, the number of independent variable is at least 2, right? So this is the main difference of ordinary differential equation and partial differential equation. Now, we are moving forward. What is the order and degree of an ordinary differential equation? So this is the basic definition of ordinary differential equation and partial differential equation. Now we look into the ordinary differential equation, as this lecture series is focused on the ordinary differential equation. See, the order of highest order derivatives is called the order of the differential equation. I think you all know that what is order and what is degree. Now, the degree of the partial differential equation is the degree of the highest order derivative is called the degree of the differential equation. So, if we see this example, then we see that the derivative is of order 2. That means the order of this differential equation is equal to 2. Now, what is the degree? Degree is the power of highest order derivative. That means degree in this case equal to 23. And you may remember that this order and degree should be always in integers, right? If the differential equation is given such a way that the powers and these things are not in integers, then firstly you have to convert those to integers by squaring, cubing, or like that. Right? Now, what is the linear differential equation? We all know that the differential equation, any types of equation, may be in linear or non-linear, like that. So the differential equation is called linear if every dependent variable and its derivatives appears in first degree only, and no product of dependent variable and its derivative occur. Fine. What is the nonlinear differential equation? The differential equation which does not satisfy the above two conditions is called a non-linear differential equation. Now, if we see this example, see what is say in condition number 1, every dependent variable and its derivative appears first degree only. Fine. See, the power, the order of this term is 2, but the degree, that is power of this d2 by dxt is 1. That means this is 1 degree. This term is also in 1 degree. This is also in 1 degree. That means, and no product of dependent variable and different term. So there is no product. You already seen here. That means this differential equation is clearly an example of a linear differential equation, right? Second example. See, we take also this example only here that we already have taken like that. So d2 by dx2 to the power 23, that is there is power of 23 dy dx and xy. See here, there is product, right? There is product of independent variable and dependent variable. And here also the power of the that is the degree of this function, degree is 23, which is strictly greater than 1. That means this is not an linear differential equation. So this is the example of a non-linear differential equation. Fine. Just a minute. So we have already covered 15 minutes of our first lecture. So let me going some more minutes forward. So now here the different types of solutions of ordinary differential equation. So any relation between the dependent and independent variable when substituted in the differential equation that reduces to an identity is called the solution of the differential equation. I think this is very basic and you all know that. I don't need to clarify this. What is the solutions? Now there are mainly three types of solutions of an differential equation or ordinary differential equations. First one is general solutions, and these three types of solutions has also occur for the partial differential equations. So let the ODE be given as, here we actually discuss these things for ODE. Let the ordinary differential equation being given as fxy, p1, p2 and pn, where pi are the yix, that is these are the derivative terms, and let the solution be given as psi of x, y and c1, c2, cn equal to 0, where ci as the constant of integration. This is called the general solution of an ordinary differential equation. What is the particular solution? Solution then obtained from the general solution by giving any particular value of the arbitrary constant is called the particular solution. What is the singular solution? These are the solutions that clarify the ODE which cannot be obtained from the general solutions for any value of constant of integration or C including plus minus infinity. This singular solution will be the envelope of the family of solutions of the general solution. See, this line is most important that you need to understand. Singular solution will be the envelope of family of solutions for general solution. Suppose there are a family of card. Okay, for the general solution you will get some family of card, and the singular solution is the envelope of that family of cards is the singular solution. So it will have no constant in it, unlike the general solution. We will come to example. Note, so a first order ordinary differential equation is linear in y dash and do not have a singular solution in the sense of the singular solution being an envelope of the general solution. That means first order differential equations or linear differential equation do not have singular solution. Fine. Mostly the differential equation have to be non-linear. And then we will get an singular solution for that. Now let us give an example of this. What is singular solution, general solution, particular solution? So if we take the example, let y equal to x y dash plus y dash q, where y dash equal to dy dx, by replacing, so this is most common form that I have taken here, and this is known as the, I think you all know that. What is the name? Uh, what is the name? I forget what is the name. So I think you all know that the form name is, I just forget. Whatever may be. By replacing, let me know in the comment section, will I just forget. By replacing y dash with any arbitrary constancy, you will get the general solution. This is the special types of differential equation. So the solution we can write as in the form y equal to cx plus cq by just putting y dash equal to c. What is the name? I have forgot. So the particular solution. So if we put any value of this c, then we get a particular solution like that. Now the singular solution. We find the envelope of family of lines by differentiating the general solution with respect to c as. So if we just differentiate this function with respect to c, then we get the value of this. Now if we put the value of c in the given equation, then we get the singular solutions like this. 4x cube plus 27y square equal to 0, which is a required singular solution in this case. Fine. So this is the singular solution. Just a second. So I think I am now stopping here because this is the first lecture and we are having 20 minutes. Fine. So this is the first lecture. In the next lecture, we will start the equation of first order and first degree, then existence and uniqueness theorem for this, then examples like that. Okay. So we'll cover one by one. So how was the lecture series? If this lecture series is helpful for you, then definitely let me know in the comment section below. Share with your friends, fine, and do not forget to subscribe the channel, because see, this written content like this in this way is very time taking. So please don't forget to subscribe the channel and share with your friends, fine. So we just start today. Now one by one we will upload the lecture series for ordinary differential equation from a basics to an high standard, so that you can solve any questions after watching these lectures. Okay, thank you, bye. So let's meet in the next video.